All right, guys, quiet. I'm recording. Now, a small sphere, a small sphere, two spheres, right? And they're going to hit each other. Okay. And what's going on? They're both identical, are they? Yeah, both identical. So the full system is M's. So we don't need to worry about any masses going on here. Okay. Now they're 1 meter from a vertical wall. So what do you think is going to happen when one of them's at rest? So this one hits it. What happens then when the first one hits the second one? And this one's moving at 0, and this one's moving at 2u. What's going to happen then? The second one's going to go towards the wall, hit the wall, and come back. The first one can either be moving to the right or to the left. Is that right? Traditionally, I think it'll be going to the right. Is that right? Because the other one's not heavy enough to deflect in the other direction. Okay. So that's what we're going to do. We're going to deal with one thing at a time, though, aren't we? We're just going to deal with the first collision, and we're going to get points on the board. Okay. So what do you think here, guys? Any idea? V1 and V2? PCM, NEL? Yeah? Okay, let's start with PCM. What do we think? M times 2u, M times 0 equals MV1 and MV2. Hey! Might not be correcting duds this week. All right. Are y'all happy with V1 plus V2 is 2u? Yeah. All right, guys. Now, NEL. V1 minus V2 is minus E, U1 minus U2. We all good? Okay. What do we get down, guys? V1 minus V2. What's the E value? We don't know, do we? U1 value? 2u, yeah. U2 value? 0. So I think we're in the fortunate category that we have two simultaneous equations, and both of them are reasonably easy. We cool? Okay. What happens when we add downwards? 2u minus 2ue, yeah. And V1 equals, divide everything by 2, and there's u into 1 minus e. Is that right? Now I'm just going to take a bit of a shortcut. Are you all able to sub it in and find V2? You happy enough with that? So I'm just going to take a shortcut. I'm just going to call V2 equals u1 plus e. Okay? Now, it's quite obvious, no matter what the E value, unless the E value is 0, it's quite obvious that V2 moves faster than V1. Choose any E value you want, like a half. If E was a half, V1 would be a half U, while V2 would be 3 over 2U. Do you get what I'm saying? If you sub in E equals a half. So V2 is always going to be faster than V1 in this situation. And that's what we're expecting, wasn't it? Because you can't collide with another ball, and then you can't hit a ball and then just like catch back up to it again unless it's slowing down for some reason. Is that right? Now we're going to work with the next collision. The next collision is the following. It's coming into the wall. The second particle is coming into the wall, and here's what happens. All right, you ready? This is coming in, and this is coming back out again. Okay. Now we're going to simplify the question. If this is coming in at a speed of 10, and the E value is a half, what does it exit as? 5 in the opposite direction. Now that's not the case we have. The E value is actually just E. What happened this time? 10. Yeah. Now it might be minus 10E because it's in the opposite direction. Right? We can worry about that later. Okay. Now we don't have that. What do we actually have? We actually have U1 plus E. Just add an extra E onto it. On the way back, it's UE1 plus E. You okay with that? Okay. Now, here's the very difficult part. When the second sphere hits the wall, the spheres are a distance 2E1 plus E apart. Now, we're going to use the simplification technique, okay? Ready for this? Here's a standard simplification technique, okay? Imagine this scenario. This one's traveling 6, this one's traveling 5. The second particle to the wall, for argument's sake, is 12 meters. You all okay with that? How long did it take the first particle to reach the wall? Yeah. So what you did was you did the distance divided by v2, didn't you? And you calculated that to be 2 seconds. Then you multiplied 2 seconds by v1, because how far does the other particle travel in that one? It travels 10 meters. So what's the distance between the two of them when it hits the wall? Yeah, it's 2 meters, isn't it? Now, unfortunately for us, we haven't got such simple numbers here, do we? We have all these variables and stuff. So we have to automate this process. So here's what we actually did. We did distance divided by v2, gives me the time. Is that okay? And then we did time multiplied by v1 to get the 10 meters. And then we did our distance take away tv1, wasn't it? Would you all agree with that? I'll pause it for a second. So we've come up with a system. It's d minus tv1, yeah? Now, here's what's happening with us. We wish we had these numbers, but we don't. That's too nice for us, right? So here's the deal. To find the time, we do distance divided by v2. And we have v2 here, don't we? So it's 1 over u1 plus e. That's our t value, right? Agreed? And then now I have to turn into 2e over 1 plus e. Now that's going to be interesting. Okay. Now, 2e over 1 plus e. Okay. Now, next thing we're going to have to do, guys, yes. It says it in the question. 1 meter away from the wall. Is that right? So it's 1 meter away from the wall. So we know the d value is 1. So d is 1, and we use v2. We have the t value. Now what we're going to do is d is what? D is 1, isn't it? Time is 1 over 1 plus e exactly. And v1 is, how comes to the use? Cancel. Okay, we're in business now, I think. So use cancel, don't they? Now, imagine this, all right? So the use cancel, and now it's 1 minus bracket 1 minus e over 1 plus e. Give them a common denominator. So I'll change 1 into 1 plus e over 1 plus e. Is that cool? Multiply in by the minus 1. What you get? And my answer is 2e 1 plus e. The next collision takes place at a distance 2e squared 1 plus e squared from the wall. Once again, I'm going to make an easier example. I'm going to automate it, and then we're going to calculate it. You ready for this? So here we go. This scenario, okay? Here's a scenario. So I'm just going to go back to my 5 and 6. Remember I made up 5 and 6 earlier? Yeah? And what we said was at the wall, there was a 2 meter gap between the two of them, wasn't there? Yeah? No, that's a 2 meter gap. Okay, now the first thing I'm going to teach you guys is, imagine there's a distance of 22 meters. between me traveling 5 and the other one traveling 6. Agreed? Have a really quick way of doing this, I do. How long till they collide? Anybody know? 2 seconds, correct. How did you do that? Add 5 and 6 together because they're coming towards each other, and it's the equivalent of something going 11 versus something going 0. This is what's called relative velocity. It used to be on the applied maths course and taken off, but we still use this trick. And the distance covered is still 22, and the t-value therefore is 2. And if you want, multiply 5 by 2, this one travels 10 meters. Multiply 6 by 2, that one travels 12 meters. Okay, let's automate the process. Ready? So what did we do? We did distance divided by v1 plus, to find the time, and then we multiplied the time by the new distance is the time multiplied by v2 to figure out how far away from the wall we were. Is that correct? Because we multiplied 6 by 2 and we said we're 12 meters away from the wall. Is that right? Now, one problem before this happens, okay? Now, I'll set this up again, all right? The problem, I'm going to set this up nicely, right? So this one's going 5. For argument's sake, this one's going 12, just before it hits the wall. Agreed? The E value is a half. So what's the rebound velocity? 6. And they're, what does it say, 22 meters apart? And then they meet after 2 seconds. So our old velocity, if that was just E, we'd be talking 12E on the rebound, won't we? So 12E would be our V2. So look at this scenario, all the way back to, sorry, we automated, didn't we? What's the automation on it? Those two formulas, wasn't it? Yeah. Now, for me, I don't learn the formulas off. I can sort of, I explain stuff back to myself using really easy examples. See the way I just made up those numbers and explained the process? I do that to myself a lot. Like, I'll just make up, it's called a simplification technique. I advise you to use it in maths and applied maths. You just simplify the problem to really easy variables, and you see what you do in that situation. Okay, so here we go. So we're gonna have fun here, right? So currently speaking, they're 2E, 1 plus E apart. Okay, one of them's at the wall. One of them's at the wall. The other one's here. Okay. Now one of them's about to hit the wall with speeds v2, wasn't it? U 1 plus E, and it hits the wall. Now what happens to it on the way back? Have to multiply this whole thing by E. So it's now UE 1 plus E. I'm not worried about it being negative. Can anybody tell me why I'm not worried about it being negative? I'm just doing the 5 plus 6 trick. Take them both as positive and add them together. That's what I'm doing here. Okay? So UE 1 plus E. What's this? So that's phi2. What's phi1? I think we had it earlier. U bracket 1 minus E. Is that right? And that's going towards it. Now what's their distance apart from each other? We calculated it in the last question. 2E 1 plus E. And if you reread the question, they want me to prove that it takes a place this distance away from the wall. You're neglecting the size of the particles, by the way. You're taking them as point particles, like their diameter and radius. Doesn't matter. Is that right? Now, here we go. Let's automate this. What's the D value? Yeah, 2E over 1 plus E. Now, I'm going to add V1 and V2 together, okay? So it's going to be U minus UE, and then it's going to be plus UE plus UE squared. Is that right? They cancel, don't they? So that everybody be happy with u over, so u plus ue squared, yeah? Okay, that's the time. And now the distance is this multiplied by what? V2. What's V2? UE 1 plus E. Okay, January sales, everything must go. 1 plus E, 1 plus E. Factorize out U out of the bottom here. What happens if I factorize U out of the bottom? U 1 plus E squared. That U cancels. That U. 2E by E. 2E squared. Left on the bottom. 1.